Hi, 5th grade. Today we're starting Module 2, Lesson 5, and we are now moving into area models. For the next couple of weeks, all we're going to be doing is multiplying and learning different ways to multiply, either whole numbers or decimals, and we're going to be using lots of different visuals to help us out with this. So to get started, you are going to need your Lesson 5 notes. They should look like this. Please make sure you have those out for this lesson. So to get started, we are going to take a look at this problem, 21 times 5. We're not going to be working with decimals for a little bit, so don't worry too much about decimals. Just worry about the whole numbers for now. So we have 21 times 5. Now for this lesson, we're going to be looking at different ways that we can multiply this number using different types of models. Now, if you look at these models behind me, you might think, oh my gosh, how in the world am I supposed to do this? And you're right, these models are not going to really help us out that much, so we're going to learn a different way of creating models today. So for example, first we have the tape diagram. And if I look at this problem, 21 times 5, it's basically saying that I have 21 groups of 5. So I could have drawn a really long tape diagram and shown you 21 little groups with 5 in each one. That's why I have this dot right here, because I didn't want to draw all of those dots. But this would all together be 21 5s. And then I have to count by 5 21 times. And that doesn't really work. So I don't want to do a tape diagram for this number. Then we have our area models. And for our area models, I would have to show 21 groups stacked up with 5 columns. And I could, I guess, if I really wanted to, count all these little groups, and eventually I get to our answer. But again, that's not very practical. That's not a very good solution to solve this problem. So we're going to learn a different way of doing this. Keep in mind this image right here. I have 21 rows with 5 columns. So I'm showing you 21 groups of 5. So I'm going to erase this, and I'm going to show you a much easier way of doing this. And you actually already are probably looking at the much easier way of doing this. So on your papers right now, you have a very long rectangle, and in this very long rectangle, it is split up like this. And the reason why we did this is that if we can split up numbers, it actually makes our problems a lot easier to solve. And I'm going to explain why. When I split up this problem, what I did is I created these smaller problems that I could eventually add up, and these smaller problems are a lot easier for me to add. So instead of trying to remember what 21 times 5 is, what I could do is I can split it into smaller facts that I do know how to solve. And the way that I broke this up, as you can see I have 20 down here and 1 over here, is I took this number and I split it, or I decomposed it into smaller parts. So for example, I have 1 1, so that's why I wrote this 1 right here, and this 2 is in the tens place, so that means if I have 2 tens, I have the number 20. So I broke this number 21 into 2 different parts. So I have 20 and 1. Yes, together they equal 21, but I broke them apart so I can easily multiply by them. I left the 5 the way it was because I can't really break down that 5 into smaller units right now. And then what I did is I left the 5 at the top, and the unit that I broke down, I put it at the sides. I put the smaller unit at the top, and you'll see why later on in the lesson. Now what I need to do is, these are very similar to the area models you guys did back in lesson 11. And for this, I can, put my finger here, put my finger here, bring them together, and the answer to this multiplication problem is the answer that I'll put right there. So if I have 5 and 1, I do 5 times 1, which is 5. So I'll put a 5 right there. And then I'll put my finger here, and bring it together, and I do 5 times 20. Now 5 times 20 might be a little bit more difficult, but remember, you can think of this as 5 times 2, and then add the 0. So 5 times 2 is 10, and then I can just add that 0 that's remaining, and that leaves me with 100. Again, these are much easier for me to solve because these are facts that I can figure out a little bit easier with mental math. I didn't have to use a calculator or set up a standard algorithm really to help me solve this problem. Now, I have what is called partial products in these boxes. So this is a partial product, and this is a partial product. What I mean by that is that these are parts of my problem, because if you look at that word partial, it has the word parts in it. So these are parts of my answer. And I have to take these parts of my answers and put them together. So I will add 100 plus 5, and that gives me my final answer of 105. And this is a lot easier to solve than trying to add 5 plus 5 plus 5 plus 5. But it also helps me understand what's going on when I solve using a standard algorithm. And we're going to see how this works in our next problem. So you're going to be moving on to problem number 2 in your notes. And this time we're not going to use any tape diagrams. We're just going to be using area models to help us solve our problems. So the next problem we're solving is 23 times 31. And what we're going to do to solve this problem is I'm first going to start by making an area model. And for this area model, again, we usually start with a long kind of sideways rectangle like this. And what I have to think about right now is which number do I want to break down to put on the side? Because for right now, there's only going to be one number that I'm going to break down and put on the side right here, and the other number will just stay just as it is at the top. So I look at these numbers and I think about, well, which number would I rather multiply up here? Because if I chose 23, that means I would have 3 here, 20 here, and then 31 at the top. And if I have that 31 at the top, that means I have to do 3 times 31, and then 20 times 31. And while, yes, it's not too bad, it's still kind of difficult. So then I take a look at the other number. Because remember, when we're multiplying, the commutative property lets us flip-flop our factors. So maybe instead I'll try 31. So if I use 31 on the side instead, I could break that down to have a 1 right there, with a 30 right there, and then a 23 at the top. So then I just have to do 1 times 23, which is really easy, and then I have to do 30 times 23, which it could be a little bit difficult, but it's definitely not as bad as what we had before. So I'm going to stay with this. And that's what you're going to be doing in your problem set later on. You're going to have to create your own area models, and you need to just think about what would be easier for you to multiply first. Now, you may also have noticed that we have a standard algorithm right here, and we're going to be also solving with our standard algorithm as well. And I'm going to show you why this is so important. Now, the number 23 is at the top, so my number 23 is also going to be at the top of my standard algorithm. Now, my first step when I go to solve in my area model is I'm going to take my number 1, my number 23, put them together, and I do 1 times 23, which is just 23. Now I'm going to move over to my standard algorithm over here, and I'm also basically going to be doing the same thing. I'm doing 1 times 3, which is 3, and then 1 times 2, which is 2, which gives me basically 1 times 23, which gives me an answer of 23 as well. Because what I did right here was 1 times 2 tens, which is 20, and 1 times 3 ones, which is just 3 ones. So I have 20 plus 3 ones right here. Now that might seem kind of weird, but don't worry, we're going to take this step by step. We have plenty of lessons to learn all about this. Now I'm going to draw an arrow showing that my partial product here matches my partial product here. Because in this standard algorithm, this right here is called a partial product. And eventually I will add up my partial products just like I would over here. Now my next step is I have to multiply 30 times 23 in my area model. And again, I could use extra math to help, or mental math to help me out with this. So I'm first going to start with 3 times 3. 3 times 3 is 9. And then I'm going to move on to the next digit. So I'll do 3 times 2. 3 times 2 is 6. And don't forget, I need to add this 0. Now I'm going to check my work over here because it looks like my partial product is 690 right now. And I want to see if I can make that work over here as well. Now what you'll notice is I no longer have a 1 here, but I am taking 30, multiplying it by 23. And I'm basically doing the exact same thing over here in my standard algorithm. I have 3 tens, which is 30, and I am doing 30 times 23. So let's see what we get. I need to add this 0 right here because I am multiplying this 3, which is in the tens place. So that's why we add the 0. And then I do 3 times 3, which is 9, just like we did over here. Then I do 3 times 2, which is 6. And I get 690 for my other partial products. I will draw a line from that part of my area model to this partial product, just saying that I've checked my work. And now I need to add my partial products together. Remember, these two little parts that we multiplied, we now need to add them to get our final answer. So I have 3 plus 0, which is 3. 2 plus 9 is 11, so I carry the 1 and I leave the 1. And then I do 1 plus 6, which is 7, which gives me a final answer of 713. So 23 times 31 is 713. Now, normally, you probably would look at this problem and think, I can't do that mentally. But just by setting up the area model, you could do it mentally by just using the facts that you know and by breaking down the numbers. Let's move on to our third problem together. It's right here on the back. And you'll get an example of how this all works, but with a bigger number. So again, I am going to be using my area model to help me out with this problem, because I'm definitely going to need help. I am multiplying 343 times 21. Now with this problem, again, area model, but I will still have my long rectangle, and I want you to think here, what would be easier to break down and multiply by? 343 or 21? Remember, we break it down like this, and if I broke it down by 343, I would actually need 3 boxes over here because I have 3 digits. So that means I'm actually going to be doing more work because I'm going to have 3 different boxes I'll need to fill in. So that really doesn't sound like a good time. So instead, let's do 21 because I know for sure one of my boxes is going to be super easy to figure out because I'm just multiplying by 1. And then this box down here will be 20. Remember, it's just breaking apart this number. I have 2 tens, so that's 20, and then 1 1, which is just 1. And that's how we got these numbers over here. And then this number is just going to stay the same at the top. So that is 343. I also need to write my standard algorithm over here. So I have 343 times 21. Remember, this number's on top because it's on top of my area model right now. And then I'm going to start solving. So right here, this problem right here is super easy. I'm just doing 1 times 343, and that is just 343. Now I can also see the same thing is happening over in my standard algorithm. I'm not worried about this 2 tens just yet, but I see that I have 1 1 multiplied by 343. So 1 times 3 is 3, 1 times 4 is 4, and then 1 times 3 is also 3. And I get the same partial product of 343. So I move that over here just to see that my partial products are matching. And then I move on to my next step. Now for my next step, I have 20 times 343. And I'm going to take it one step at a time. I'm going to add this 0, so I don't forget about it because I know I have to have it there. And then I'm going to do 2 times 3, which is 6. 2 times 4, which is 8. And then 2 times 3 again, which is also 6. You just multiply 2 big numbers together, and we're able to get this whole number right here. Now, I'm going to do the same work, but in my standard algorithm. And again, I'm not going to worry about that 1, because I already dealt with that up there. but you see that I have 2 in the tens place. So I'm doing 20 times 343, just like I did over here, and we'll take it step by step, just like we did in the area model. Remember, I had to add that 0, so I'm going to do the same thing here. Then I have 2 times 3, which is 6, 2 times 4, which is 8, and then 2 times 3 again, which is also 6. This partial product matches this partial product, so I can now start adding up my numbers. So I have 3 plus 0, which is 3. 4 plus 6 is 10, so I carry the 1 and leave the 0. Then I have 1 plus 3, which is 4. 4 plus 8 is 12. Again, I need to carry the 1, leave the 2. Then I have 1 plus 6, which is 7, which leaves me with a final answer of 7,203. Again, another really big number that you're trying to multiply that really wouldn't work in like a tape diagram or other models like that. But when we have this simplified area model, it works really well for us. And then also it shows us what is happening behind the scenes in our standard algorithm. So 5th grade, you are going to try this next problem on your own. You're going to do 231 times 32. I need to see your area model, and I need to see your standard algorithm from your area model pointing towards your standard algorithm partial products as well. As always, if you ever need any help, please let me know, and good luck today, 5th grade.